So at the beginning, we talked about alternatives to passwords and why in the world, what would you use them for anyway? Um, and currently, the number one onboarding process, the reason the device has any kind of onboarding is so that you can stuff the Wi-Fi password into the device so that it can get on the internet. The question of how do you manage the device and how do you talk to it and all that stuff, that seems to get a second problem, a different problem. But this is what I'm going to talk about now, how this happens. And if you do things in an interesting way, you can actually use that security that you've created to manage the device, to turn the washing machine on or off, or the refrigerator to tell it to order more food or whatever. Um, you can use that to set the Wi-Fi key. And this is where actually it'd be really lovely to have um, a well accepted set of standards. And I gave the slide earlier on with quite a number of different ones. So we're going to talk about 4 or 5 different ways that happen. And most of them look like, in some ways, or are like OAuth 2. So if you've ever gotten to a website and it says to you, would you like to sign up or sign in with Facebook or Google? Then you've used OAuth 2. And you may be very familiar with this and you may hate it, you may love it. I encourage you personally to use it whenever you can, because it's much better to rely on 1 or 2 BMOFs to get your passwords right than to try and keep track of them all yourself. Which one did you use? My biggest problem is I never remember which one I used. But there's arguments both ways. The key thing is that this protocol is really well thought out, and it's called version 2. It's gone through a lot of effort, and at the IETF, we're talking about a version 3, but it's mostly going to be 2.1 extensions. So you see all these different things with different grocery stores and other stuff like this that let you log in with this stuff. Some of the stuff is so invisible you don't even see it as well. It's very interesting. So the simplest one, as we showed, is one where you scan some kind of a thing. So device provisioning protocol from the Wi-Fi lines does this literally. You just basically scan a QR code that contains the public key of the device. And the assumption is that you can't see that QR code unless you have access to the physical access to the device. This involves doing some crypto operations. 5 years ago, people were really scared of those. They said it was too small, too slow, too expensive. But at this point, every single mobile class processor has ECDSA as a hardware accelerated extra. They're usually faster than anything that you had 5 years ago, faster than PCs doing it in software 5 years ago. There are some difficulties which I don't want to go into in how DPP works and how it uses the Wi-Fi channel. It's not the only system in town that does this, and you can effectively invent your own if you like to. There's a lot of interesting ways of doing that, and I suspect my LG washer, for instance, might do something like that itself. But the key thing is that there's a private key in the phone in your app, and you have to keep that secure. And we talked about that earlier. Okay, and you have to keep it available across phone resets and loss of phone. And for quite a number of devices and environments, you're like, yeah, okay, it's all right. I will put it in the information that I let Apple or Google back up to their cloud, and I'll restore it if my phone gets factory reset or I get a new phone. And that's good enough. That's a good enough security. It's not necessarily life and death. I don't expect someone to attack Apple or Google with a national security letter to get my washing machine keys out. So that's okay. And there's other ways of recovering it. You could offer to print it to a file, for instance, with a big QR code and scan it back if they wanted to. That's another really good way of doing it. That, of course, assumes that you figured out how to onboard your printer from your phone, which may be a problem. The printer, although point out, can print a QR code to have you on board it. I haven't seen that happen, but I assume it will happen. So the next process is you actually use OAuth 2. So the version I showed before, the previous slide, didn't involve any part of the cloud. You, in fact, probably didn't even need to be on the internet. You could have been in a cabin in the woods and do it. But in this case, what you do is the device somehow makes a relationship to the cloud, and the client gets some information from the cloud, and the cloud informs the device that this client is now its owner. And that's pretty much it. And then you speak directly to the device. So the important part is, although the cloud is involved in authorizing the device, the cloud is not involved in operating the device. The client speaks directly to the device directly. And a lot of people are much happier with that for a lot of things in their home. The downside is that the cloud can actually change who can operate your device. It, it's literally the script um, for a whole bunch of different movies. I'm trying to remember one with Tom Cruise, that, all your devices are turned against you by some evil operator. And that literally is the situation that's possible here. But at least you know that you could, once the device is in your control, it's in your control and you could talk to it directly. So another version of this is essentially puts the authorization server in the device. And this is very similar to the first slide. The difference is that now it's very regular and very standards based. And now the process of how do I share this device with the rest of my family? How do I keep my uncle, who I was visiting, from continuing to control my washing machine after he's left my home? That's all very clear because that's all been defined very, very well, and it works very well. Is it going to work in the teddy bear price range? Maybe, maybe not. Will it fit in a Raspberry Pi? Absolutely. So there's a class of devices where this works really, really well, and some smaller ones where this works less well. And where you are and how it works for you depends a lot upon where your market is and things like that. And there's a lot of different protocols and variations. So if you see, for instance, Oauth 2 is based on JSON, uses HTTP and signatures with a protocol called Jose, which is JSON object signing and encryption. And there are constrained versions that run over very low power networks that use, instead of JSON, they use CBOR. Instead of HTTP, they use a protocol called CoAP. And instead of Jose, they use COSI, which is CBOR object signing and encryption. These are all IETF specs, and they are well supported in pretty much all of the ecosystems you can imagine. Most of the primary author of some of this work is a Microsoft guy, and we have Amazon, Google, Ericsson. The list goes on of people involved in this process. One thing I like, as I mentioned, is magic URL by email, right? When you want to get access, you do something and you get an email, you click on it and you get access, and that's it. There's something in there. That email and that process is probably OAuth 2 again with the server. It's just that the instead of coming over the network directly, it comes by email for you to click on that link. And there's some nice advantages about this. One of which is that everyone has an email or thinks they have an email. The email addresses are relatively unique. And when you lose access to your email, well, that's Google, Yahoo, AT&T, whatever's problem, not your problem. So you'll get them to do all the password resets and all the support process for that. So you've just outsourced that huge problem of that. But it does mean that they are responsible, and if they screw things up, then your device stops working, and it's an issue. On the topic of treadmills, it turns out that, by the way, they are internet connected. They apparently do have screens that can watch YouTube now, and I learned this morning that the lack of IPv6 support in the treadmill has kept Google from making their offices completely IPv6 only, because the treadmills don't speak v6, and people want to exercise and watch movies while they do this. So treadmills are, in fact, smart devices. They are online, and they are apparently more ubiquitous use than I would have imagined before. So some conclusions. So the passwords, we have a long history of passwords. It's something that you know, And in the days of a shared terminal room at the university, where computers were big and unportable, well, there was nothing else that you could use. The password was the only thing you could possibly ever use as a credential, and that's why we started using them. And nobody really has loved them for years. It's always been a pain. Even back into those days of terminals, there were hacks and exploits where you got people to disclose their passwords, phishing attempts on that, and it happened. Default passwords are regularly exploited. The article I can share in a moment that just came across my desk includes the fact that there were default passwords burnt into the ROM of IoT devices, so those devices could talk to the cloud parts, and those passwords are being exploited, and the people who have these devices in their transportation systems are unable to replace them or upgrade them apparently quickly, and it will be about 2 years before they get them all fixed. So that's pretty astonishing, and in this case it may affect lives. I don't know the details. Whatever password you provide, please ideally make the user change it, and let them pick a strong password that their browser has generated for them and to store it there. That's really important. If you're going to have no password, then the device has to really always be offline or unusable until the password is set, or at least all of the internet functions have to be online. So if your stove doesn't work until you set the password, that's probably an issue. But if your stove can't be controlled over the internet until you've walked up to it and physically set the password, then that's probably a good idea. Don't make your default passwords related to any public information on the device, serial numbers, MAC addresses, or anything else like that. It does not work, and it's not going to pass the regulation. Whether or not you can make a, encrypted version of that public information and do it right remains to be seen. Avoid passwords are not always the best choice. Look at the automated onboarding functionality. There's a lot of different specs, but there's more coming out. But they're all relatively well thought, and they all have fairly good niches. And there's quite a number of ecosystems: Zigbee, Thread, Fairhair. The Fairhair is building automation, lighting systems, for instance, that they have picked one and they say you'll do this and life will be good, and they don't use passwords. If you're going to integrate into the cloud, well, if you're going to do that, you might as well trust that relationship and leverage it, particularly to either eliminate the passwords or at least to be able to recover them better. And finally, the devices really don't care who a person is. So in some sense, the fact that the login as admin is irrelevant because there's never usually any other choice. But it makes people understand, we log in with admin, and but that's the password that really matters, not the person. Thanks.
Michael, thank you very much for taking us through all the twists and turns of passwords in smart devices, and also for those really clear concluding remarks.